Hello everyone, good evening and welcome to this month's PyLadies, and I am Vicky Toomey Lee and I have my co-organizer Lee, which I should keep forgetting to announce every single month, and I also have Michael, my other half, who's monitoring live chat. So welcome again, and if I'm going to go through announcements, and then our speakers will then give their talks. So if anyone have any kind of questions, please post them on live chat there on YouTube. Do feel free to introduce yourselves and have a wee chat. So let's go through the announcements. So first of all, I'd like to say thank you to sponsors. So for Dublin Maker, who's or using Zoom from Dublin Maker, who is actually funded by SFI and supported by DCU. So it's nice to be able to use a Zoom that won't cut off after 40 minutes. And also our friends from Magilabs, I left the discount code there because they said that it's we can keep using that discount code. We go to their store in Magilabs. So this evening we have two talks. We have Nabanita talk about scraping Wikipedia using SPARQL and DBPedia, and we also have lightning talk from Shivendra about shipping good Python code using DeepSource. So agenda, yes, we're going to start the event, welcome announcements, then followed by two talks, and then if we have time, we can ask Nabanita and Shivendra cute questions afterwards. But do please just type in your questions into live chat, and Leigh and Michael will actually let me and the speakers know what question we're asked, and we'll ask them afterwards. So some other announcements. If you don't know already, EuroPython is online this year, and their tickets are now available. I should have put the dates down. It's in July. I will update this doc. You can find this script pad on our Meetup page, this month's Meetup page as well, so you can view it. They do have financial aid for discounted or free tickets, but these do not include training classes. So hop over to europython.eu for more information. If you want to volunteer for EuroPython, do click on that link or head over to EuroPython, and you will find, I think there's a contact email address that you can actually ask about volunteering for EuroPython, which would be great as well, because then you actually know what you kind of won't be surprised if when they come to Dublin next year, you're already volunteering. You know a lot of the folks already, so it's pretty cool. And plus, you get a chance to get a free ticket if you're a volunteer also. So an organizer from the, I think it's a data conference, ODSC Europe. They offered, I think if you go through that link, there's a general pass free of charge for PyLady members. So thanks ODSC Europe. I mentioned Dublin Maker earlier on as one of our sponsors, our supporters, or partners. They are back this summer, and disclosure, I am on their team as their maker advocate, so help them coordinate the festival. But it's open to everyone, it's free, and it's going to be virtual online using the platform called GatherTown. People who haven't checked it out, go to gather.town. It's really cute. You can run your own virtual events. It's like playing a video game. But more information will be coming along at doublemaker.ie. I always put this up. I always leave this up. For any, we use there's a platform called Dev2, and PyLadies has kind of account there where we post articles and things like that. So if anyone else is on Dev2, let me know. I'll send you a secret key that you can join as well. And other people beside myself that's on it is Chuck and Lais. Who Lais spoke last month, and she'll be back next month as well. We are looking for speakers for PyLadies Dublin from September onwards. We the next few months the slots are full. The August one will be announced soon. I'm just working with the company who's going to be sending speakers and just firming up all the information. And our next PyLadies in June is on the 15th, and again it's going to be virtual. And as I mentioned, Lais will be giving a talk on Newbie is Not Nobody, how can you contribute to communities even if you are new. So check that out. And then, as I said, July, we have Boyan, who will be talking about fast API lambdas, PyTests, and other cool things. And then other Python related events, Python IE, they're on the second Wednesday of each month. So the next one will be June 9th. So check Meetup or Python IE for what the events topics will be. I think they normally open up the RSVP about a week before the event. I won't, I actually haven't listed all the events here in the script pad, but just want to show you that some kind of diversity in tech events. There's How She Did It, women, if you're interested in women tech entrepreneur series. There's also Celebrating Social Entrepreneurs, African Edition, and Block W Ireland, and Women Code Belfast, Bites and Brew. So those are kind of the few events. It's linked off CryptPad. If I'm missing any events, Irish Tech Community events or Diversity in Tech events, just drop me an email at dublinpyladies.ie or .com. Sorry. And that's it. And for anyone who's curious, because I have got queries about resources and stuff for Python, right at the bottom of that CryptPad and all the other collaborative pads past few months, we have kind of a resources of all where to go to if you want to learn about Python, or if you want to do some more intermediate Python kind of. So here are some of the resources, and if I'm missing anything, feel free to let me know, or so I can add to the list as well. So without further ado, I'm gonna switch over to Nabanita in a sec, and to get her all set up so she can actually give her talk about scraping Wikipedia using SPARQL and DBPedia. So okay, be right back. And where's the be right back button? Oh, there it is.
Hello, everyone. Thank you for being here, listening to this talk. So I'll be talking about scraping and getting data from Wikipedia using SPARQL, Wrapper, and DBPedia. A little bit about myself. So my name is Nabanita Roy, and I work as a data scientist in ACI Worldwide. I did my master's a couple of years ago from Trinity College Dublin, and I studied about SPARQL, linked data, open web, these kind of things in knowledge representation class. And it kind of captured my interest. So I did my own tinkering with it. And then I found out, because I'm a Python person, so I found out that SPARQL Wrapper is a Python wrapper which is available to query Wikipedia using SPARQL. So you find most of the implementations are in Java. So here, this is for Pythonistas like us. And with that, I begin my presentation. We'll be talking a little bit about Wikipedia. So we all know what Wikipedia is. It's a digital encyclopedia, and if we are looking up for anything new, we would generally go to Wikipedia. We'll find descriptions of it. We'll find extra information about it. We'll find different links from it. So it extends, different domains. It's also multilingual, so it's not just English. It goes into Spanish, French, etc. There are other, so it's available in 321 languages. And it's freely accessible. And the best part is it's automatically evolving. So it's basically crowdsourcing stuff, hence the data. So if there's an event yesterday, so today you will, or yesterday itself, you'd find it coming up on Wikipedia. So it's automatically evolving. People are putting these data in Wikipedia. And if you look at Wikipedia pages, you'll find they're all structured in as an introduction at the beginning. There will be a historical background if there's any to that particular event or a person that you're looking up over there. If it's a country or a city, it'll be about, it'll have their climatic conditions, the geographical information about that place. So it's pretty much structured information over there, but it's in natural language. And if you see in the right-hand top corner, you'll find a card like this on the screen, and it's going to have more factual data over there about the particular event or a person that you're looking up at. So, and this data, how to get it? So people would traditionally use web scrapers to do that. But since this data is crowdsourced and it's so much publicly available, then the idea over here was to create a linked open web of data. And that's why the whole concept of DBPedia came in. Now, DBPedia is a crowdsourced community effort again, and it's basically stores all the semantic information and the structured information that we have in Wikipedia and all other Wikimedia projects, and they're all stored and given a structure to get stored in a way that we can retrieve it easily using a particular query language, which is SPARQL that we'll see later on. And it's also like Wikipedia and all Wikimedia projects, they're available online, and it is in the form of linked data. Now, from the idea of linked data, you can understand that these data, or data about entities or things, person, event, that has happened, about institutions, organizations, so they're all related to each other. You can see what kind of a meshwork it is, because all the things in the world, they're all interlinked with each other. So that's linked data, and this is one of the most famous diagrams of how linked data could look like in real world. And just to take a closer look at how linked data gets formed. So I'm looking at PyLadies as an entity. You'll actually find their DBPedia page in linked data format on, if you visit the dbpedia.org resources. And so if we have PyLadies as an entity here, and we know that PyLadies exists here in Dublin, in London. So I've just taken 3 random ones, and then in New York. So they're all these location entities, they're all related to PyLadies, and how PyLadies' locations are New York, Dublin, and London. So that's how they are interconnected. Then we look at another entity, which is called organization. Now, PyLadies is a type of organization. So PyLadies is also connected to the entity called organization, and so is women in AI, women in computing, women who code. And they are all types of organizations. So they're all linked to organization. And I know women in AI because I work with them. It's also there in Dublin. So one arrow should also point from women in AI to Dublin, similar to what PyLadies is. And in fact, all of these other organizations, they have locations in these Dublin, New York, and London. So ideally, all these entities should be interconnected, but I just wanted to keep this simple. So I did not, but ideally they should all be connected. And then like we see these relationships between two entities. We could also have just a value for it. And for example, just the website for PyLadies, it's just a simple string value or a literal in web language. And then another example would be PyLadies has a relationship with Python programming language. So it is an external link on their page, on the Wikipedia page. So PyLadies is interconnected with Python programming language, and Python programming language also has a link to PyLadies, so that the arrow goes both ways. So they both have the same relationship as external link to each other. And then the designer of the Python, you'll find the name of the designer of Python programming language as well there. So this is how basically, this is just a fraction of the entire open web, linked data, right? And this grows. And so just summarize why we're looking at DBPedia, because it contains all the knowledge that we have from Wikipedia. It's crowdsourced and it's continuously evolving. And the most important factor over here is it retains the semantics of information. So it retains all the relationships that Python is a programming language, that PyLadies, one of the locations of PyLadies is Dublin. It's easily understandable from this data. And then it is also easily accessible because it's there in the open web. And best for us, we have a Python wrapper available for us to query that data. So here we it brings us to how do we query this data. So it's called SPARQL. The full form of SPARQL is SPARQL Protocol and RDF Query Language. It is a semantic query language which retrieves data for us, which allows us to manipulate the data stored in RDF format. And very quickly, what RDF format is, so it's a resource description framework, which is a standard model for data interchange on the web. So a resource description framework has a particular data representation format, which is a little different from the normal data structures or data storage text that we have. So that data representation format is triple. It comes with a combination of subject, predicate, and an object. The subject is basically the entity, and object is the value of the relationship it has with the entity. So Python is a type of programming language where Python is a subject, predicate is the type or the relationship that Python has with programming language, which is another entity, and that programming language is the object, which is the relationship of Python. Okay, it's a bit confusing, but it's very it's pretty much structured. So all information is expressed through these triples format. And here is a comparison of how a Wikipedia page would look like, and on the right hand side how a DBPedia resource or the particular PyLadies entity would look like. So on the left, you can see this is a Wikipedia page where you have PyLadies is an international mentorship, blah, blah, blah. That's the introduction that's there in the abstract. So that introduction or understanding in a paragraph, what is this entity all about, is mapped here in DBO abstract, which is the summary of what that entity stands for. We also have at the bottom, if you see, so you can see DBOs over here. So DBO is a set of vocabulary which is particular to DBPedia. And then we also have a few other examples, the DBR, FOF, SCORS, Dublin core. These are basically, you can think of it as from programming perspective, you have got a class and you've got these attributes which belong to this particular class. And similarly, for example, FOF stands for friend of a friend. So it basically has vocabularies or relationships which describes a person or an entity. So it's going to have a name, it's going to have a full name, it's going to have a last name, a birth date, gender, all these kind of things come under FOF. So it's a vocabulary which describes relationships that any FOF object could have. In explaining this in programming language, OOPS model. And PyLadies Wikipedia page is basically an URL, and the PyLadies page, a DBPedia page over here is an URI. So URL is for any web page on the web, and URI is for a particular resource which is there in the linked data or in the open web. So there is a distinction there. And as you can see, just to see the mappings there after abstract, we also have all these different links coming up, and those links are there in the vocabulary as DBO, wiki page, wiki link. So these links are mapped here in the resource list of PyLadies. And the last takeaway from this page is that how these are, the data is there in 2 different languages. So one, the abstract is available in Spanish, it's also available in English. And it's just not restricted to this. So probably for PyLadies, it's just these 2. But for others, I have seen multiple different languages coming up there. And so how to construct the SPARQL query? The structure is pretty much similar to SQL queries. So it has a select, so it selects these particular variables, and where you have to tell what is the relationship of a particular subject with this object and what you want from there. The question mark here determines that these are all the variables that we're looking at, and this is, say, the most basic query in SPARQL, and this is supposed to retrieve all the different subject predicate object relationships subjects present there in the linked web come up. So this is like select star from star of SQL. And this will probably give you a better understanding of how it works. So if you select question mark entity, question mark name means select these 2 variables from where entity has a relationship of, or a property RDFS label, and get me the object. So all those entities which has a property RDFS label, some value in it are going to be taken up. And if you retrieve, say, something in an HTML format, it's going to have a table which contains two columns, one for the entities, and the second column would contain the corresponding labels for that particular entity. And this is pretty one of the simplest ways that I could explain it. And so the prefix over here is basically telling which vocabulary do you want to use. You could actually use this entire link here instead of RDFS. But if you just want to make your query look much more cleaner, then you can just use RDFS label here and use the expanded version of it up in there as prefix. And this is the query that I have used for my use case. So my objective was there to look up all the athletes and the distribution of their genders, look at their heights distributions, and then just get their abstract to do some natural language processing stuff for myself. And here I have used a distinct because I had multiple duplicate results coming up because of the different data types, or not data types, because of different languages. And just to explain a little bit about this query, so this question mark A is my subject. So I say it, so A here, the second A here stands for RDFS type. So is a relationship is just represented with a, it's equal to RDFS type. So select all the entities which is a type of athlete. So it's enlisted as a DBO athlete. And then get, so this semicolon says that everything after the semicolon refers to this particular entity that we have begun with. And a dot here means stop. So we are not referring anything written after this is not, selection like this is not related to this particular entity. So question mark A, select all the athletes, then get their date of birth, height. The hypernym was a special vocabulary which used to say what kind of athlete they are, but the distribution, but the values were not very, were not correct many times. Then get the gender, get the name and abstract. And here optional means, so basically this query, if I had included DBO country, question mark C before this dot, it would actually eliminate all those athletes who did not have any country enlisted in it. So that's why I put optional country to get all the athletes, irrespective if there is a country associated with that entity or not. And then I just used a filter on the language of question mark name here. And I say that I just want them in English. And at the end, limit and offset, similar to SQL, so I just limited it to 10,000 row retrievals. That's because when you use SPARQL in your Python wrapper, it's just going to get 10,000 rows every time, and it will not get more than 10,000. So what I had to do is I had to use a for loop, get the count of the entire set, and set a range and give and then set the offset value every time. The next, for first iteration, it would start with 0. The next iteration, it would start with 10,001, and then 20,001, and so on until it completes. And because I was preparing for this this demo, I figured out that my solution was not working couple of days back, and that was because hypernym and fourth gender, these vocabularies has been removed. I don't know why, but I think it's because of some of the quality issues that has come up, because gender is perceived as only male and female, and that definition is challenged at the moment. So I think because of all those things and hypernym, we'll see why they're not really, it's not always representative of what we're looking at. So these two things have been removed, and this is the current query. It's there in my solution now, so it's working. But it's just that I cannot get the gender information, but we could extract that information from the abstract, because I'm getting the abstract, and it's going to have a higher percentage of he's or she's in that abstract, and you can just do a work around it. And that's for my future use case. And so I'll go a little bit to the demo of how I did this. So first and foremost, you would need to install SPARQL wrapper. That's a library. I have it installed already. Then I imported all of these different Python libraries, pandas especially, and JSON normalized, because I'm going to get the response in JSON. So another advantage of using SPARQL is the retrieval formats you could choose from a range of those. So if we take a look at this. So this is how a SPARQL endpoint would look like, and you can query DBPedia from here. This is a query that we were looking at earlier with entity name, where entity RDFS label name. We're looking at all the entities, and we're trying to get their labels here from this query, basically. And results formats, these are the different types of, so HTML, spreadsheet, XML, JSON, JavaScript, turtles, N-trippers. There are different formats available to get your results in. So if I execute the query, you get all the entities here on the left and the name, or because I set the variable name. So the column name is name here, but it's actually going to be label. So these are all the label values of these different entities here. So if you click on this, so this is another entity or a entity here, and you see the RDFS label is software. So this is what we were trying to retrieve from there. So we need to initialize this which SPARQL endpoint we are trying to look at, and basically SPARQL wrapper sends this query to this endpoint and it executes the query. So I have to initialize that. The next task would be to write the query and pass it to this object that we have created, SPARQL.set query. So I've set the query there, and then I'm setting the JSON, the format of the result. So I set it as JSON here, and then this line SPARQL.query convert executes the query, and I get the results here. So I use pd.json normalize. Basically, I actually don't need this at all. And then I get the results. So result head. Actually, this result contains 4 rows and 3 columns. So look how we looked. We actually wanted to get just, we thought we'll get only 1 column, but it actually gives me 3 columns, one containing the language information, the other one containing what type of data it is. So these are really handy if you're using much more data. And then next, I actually put them all into a function. It just makes it look clean and it's reiterable. The next one I did is I wanted to look at the label of PyLadies, and I wanted to get the abstract. So what does it say? What does Wikipedia say about PyLadies? Printed the query there and I executed, and you see all these different columns we get. So there are 3 for object and 3 for abstract. So the type, language, value for object, and type, language, and value for abstract. And you see, we were just looking at the Spanish and the English versions on the resource page, but here we have Arabic and I don't know, probably this is Portuguese. Yeah, maybe. So there are different multiple versions here that come up in the query result. And then last, I try to just take only the English versions of the abstract and label, where I use filter the language of label, and so AND operator is fairly simple, double ANDs, and or for the pipes, double pipes. And we get only one result, one row here, which is where the value is just the English language version of PyLadies label and the English abstract. Okay. So that's how you use SPARQL. So I have this little solution here. So what it does is it's basically just to reiterate and store it iteratively gets all these responses, the results for a query that I give in here, creates a new folder in which it stores the pickle file or the CSV file that I get from this little query. And all the queries I can store here, and I just have to, pass an argument to say which query to pick from. So I just did only one query so far, so I don't know how it works. It's not the best solution in the world, but it just works for me. And the data that I retrieved here is about, I don't know if I will get this here. Just a second. So basically, this is how the notebook looks after I did some data analysis. I used Plotly so it wouldn't show up all the data here, all the charts here, and you can see the main focus of my study here was, number one, to look at how accurate is the hypername field, And it looks like it's got footballer, it's got goalkeeper, it's got defender. So the granularity of the athletes, what kind of game do they play? It is actually really sparse and depends on who knows what. If somebody knows that this person is just a footballer, so that person has just said that it's a footballer. If somebody knows that it's that this person is defender, probably then that person put in defender for that particular person. And this is for the males. So the sport's played by males, and it's pretty much dominated by footballer here. And this is for females, where it's even a little bit more distributed. There's player which stands out amongst all. It says that it doesn't, so there's no level of granularity present in most of the female athletes. They're on DBPedia. And this is the stark distribution of male and female athletes in DBPedia. So it's 96,000. And this one is around almost around 12,000. So there's massive difference. And I think because of this, they have stopped the gender thing. So if you scrape the data right now, you wouldn't get it. This work was based on my old data that I scraped last year. And then I did a little bit, looked at the height. Now you see their height is 200, where the height should be around, 0 to 1.5. And these really cannot be in the same unit. So what I did is I just divided them by 100, just tried to get all those outliers, handle those outliers, and bring them into a consistent structure. I still don't know how good this data is, but this is how the distribution of heights look like. And then the top 10 countries, we have United States, Russia, Canada in the top. I thought that Russia would have a little bit more number of athletes as compared to the United States. Not sure how good this data is. And at the bottom, so this reveals the problems in the data where you've got say Kingdom of Romania, and then here you have England at the 2010 Commonwealth Games. So these are all in the country data in DBPedia. So Japan at the 2010 Winter Olympics, these doesn't really give you the right picture. So these are some inconsistencies in DBPedia. And these are a few kind of observations that I made, and that's mostly these things come up because it's crowdsourced and people enter this to the best of their knowledge, and sometimes their extraction methods then might not work in the best way. So all the challenges of NLP ideally comes up here. And so I'll just conclude with this last demonstration here. So you always don't need a SPARQL query to get the data. So this is one of the traditional ways of scraping data from Wikipedia. For that, you need to install Wikipedia. That's another library. And you need actually Beautiful Soup for to install. You don't actually need MediaWiki API because Wikipedia actually has extended it to cover all what MediaWiki API does. So import everything. And wikipedia.search, actually over here, if you enter a keyword, it'll give you all the list of pages that would come up on that search on Wikipedia. So if you execute this, wikipedia.search is going to give you all the pages here. So COVID-19, pandemic, vaccine, blah, blah, blah. And from here, you can get, say, I actually did PyLadies first. That's why there's a comment there, I'll remove it. So I stored the first page as a Wikipedia object as wikipedia.page, and I pass the first page. It has to be a page name, otherwise it'll throw you an error. So it is a Wikipedia page type object. If you want to look at the content, you can just do .content, and you can see everything that is there on that page. So it's a long text here. about COVID. You can get the URL of that particular page. You can get the categories in there. And you can also get the images, which is also useful if you're looking at, if you want to create your own database for computer vision, you can get these images. And then just one drawback of this solution is that it doesn't give you in the contents, it doesn't give you all the tables. So there's one way of getting all the tables in here is you have to use the HTML. So .html gives you the HTML version of that content page. And it'll let you use beautiful soup to parse that HTML object. And then you can find the tables. So if you look at soup, it's going to give you the HTMLs. And you can find all the tables like so, because the class label would be wiki table. And in this page, there were 2 tables. I can see the first table here as the first tables element in the list. And you can obviously go for iterate through th, tr, td and get the headers and the row contents for a CSV format. But the easiest way to do is just to use pandas read underscore HTML method and just, sorry, I didn't. So I could just read HTML from this, convert the tables into string and just get the first object for the first table. And the table comes to your data, whatever you have on Wikipedia page, you get that table here. And then for the second table, just do the same thing and it's here. So, well, that's about it from my side. And I still have 5 minutes to spare. Do you have, I have a few references here just in case you would want to look at these ideas that I introduced today further. And thank you very much for listening to me. I'm open for questions if you have any.
Yeah, we have one question.
Yep.
So far. So what is the benefit of using DBPedia over Wikidata?
Wikidata.
Yeah.
So I have never looked at Wikidata.
Okay.
So I have no idea.
So the question was asked by Rebecca, who actually runs the Wikimedia Ireland kind of editing nights, and also Wikimedia Ireland. She's part of that group. So I suppose the question to probably ask Rebecca, who what is Wikidata, I suppose. And I don't know. Yeah, you shared your screen there. Yeah.
Yeah.
So we don't know the answer to that question. I think it's probably like a question until you find out what Wikidata is.
Yeah.
Maybe Rebecca can type that answer in the chat, and maybe it'd be something that you can have a look at, and if you're curious enough, and seeing what the difference is with Wikidata as opposed to DBPedia.
Yeah.
But yeah, Leia's just asking if there are any more questions for you. But if not, we have a minute left. So if it is, we can leave it to the end if there's time left. And I'm just gonna the intermission slide, so I can just get so I can get Shivendra kind of ready. So be right back.
Hi everyone. The talk is about shipping good Python code using DeepSource. And a short introduction about me. I'm Shubhendra. I work as a developer advocate at DeepSource. I'm also Mozilla representative in India. And I've been volunteering at PyCon India for the last 3 years. So that was about me. Let's start. So let's talk about modern software development first. So in modern software development, we use continuous integration and continuous deployment to deliver the software to the production environment with speed and safety. And in CI, each change done to the code base is automatically tested and as early as possible. And continuous delivery is followed by the testing that happens in continuous integration and pushes the code to the production. This makes the version of your code accessible to all. So where comes the code review? So code review is also the part of the workflow and is done on the CI side of the pipeline. And because the bugs are most likely to be produced in this spectrum, code review is basically the practice of concisely checking the code and concisely checking the code for code quality issues and giving feedback to the author of the code to fix those issues. So let's talk how code review is currently done. So it's mostly manual and is done by the reviewers. And reviewers rely on the tests which are being written by developers to ensure the correctness of the code. And reviewers drop comments on pull request and wait for the author to fix it. This is a back and forth process. And there are some problems with the current workflow, like reviewers are humans. And if the change set is large and humans are prone to miss out on spotting errors. So to err is human. So this is an obvious correlation, right? So repeated comments. Reviewers have to repeat the same nitpicks or comments over and over to the other developers on the team. So what it means that suppose I'm working with a team of 10 developers and the developer makes a pull request. I'll spend some time on that pull request and put 10 to 20 comments on that PR. The author of that pull request will fix those issues. But then a new developer comes and make a new pull request with the same issues. So I have to point out those mistakes again on that PR. So this is a huge problem with this workflow. And you can't just detect all the issues by taking a look at the code. Like performance issues have been often overlooked in this workflow. Let's talk about correctness versus quality. So tests only ensure the correctness of the code, and this can be measured by tracking test coverage. And by quality, I mean issues like anti-patterns, bug risk, performance, style, and docs. So those who don't know about these types of issues, let me give a brief introduction about these issues. Anti-patterns are basically those issues. Anti-patterns are basically the way of writing code which lead to the poor design, and they affect the maintainability, readability, and performance of the code. Bug risk are basically those issues which cause errors in the code or breakage in the production. Performance issues impact the performance of the code being executed by slowing it down. And style issues relates to the violations of code style guidelines. And documentation issues are raised when the part of the code is left undocumented. So yeah. And security issues are basically those issues that can potentially be lead to the compromise the security of the software. Let's talk about the existing workflows to ensure code quality. So currently rudimentary static analysis is mostly used, and it is the process of analyzing a source code for code quality issues without actually executing the code. So let's talk about how it's done, mainly by using IDE plugins or using open source linters. And in case of open source linters, it is done by done as a part of CI builds or pre-commit hooks. So, but there are several drawbacks in using rudimentary static analysis. Like for ID, it only works for a small team. If you are working in a large team, you can't ensure that every developer on the team has used ID plugins and then push the commit. This is the drawback. And for open source linters, so for open source linters, it comes with a burden of maintaining several RC files. Like for coverage, you'll have coverage.rc file. For pylint, you'll have pylint.rc files. And as the number of programming languages in the project increases, you'll have to maintain the number of RC files also increases in the project. So that's that. And yeah, so linters throw basically open source linters throw thousands of lines of logs. So that is actually hard to read and understand. This is a great example of that. So there are several drawbacks, like non-critical issues, like style issues can break the build, and false positives in rules. False positives, let's take an example like bandit, which is used in Python to raise security issues. But linters don't actually have the context of the code. So bandit raises issues in test files, so which is a false positive. And no auto remediation. Suppose an issue occurs in 30 files. So one has to manually fix those issues in 30 files or write an AW case to fix them all. So which is actually very painful. So this is where DeepSource comes into action. So DeepSource is an automated code review tool that helps developers to fix and developers to find and automatically fix code quality issues. It continuously scans changes in code and categorize the issues, and also allows you to format the code continuously. So it also integrates with the code review workflows like GitHub, GitLab, and Bitbucket. And it also runs code quality checks on every pull request or commit that is made on a project. So, but why DeepSource? So it has single file configuration for all the languages. Let me give a quick demo of that. So here's a demo Python repository on my profile, which I'm actually running DeepSource analysis on. So I'll show you how the configuration file is set up. So when you are actually integrating DeepSource for the first time on a repository, it will show the onboarding screen, which is this. And here it has detected that the project is on Python. It has automatically chosen its environment, and you can add another analyzers too, like Go, Docker, Ruby, if your project has those languages. And it also gives you the option to add formatters like Prettier, Black, YPF, AutoPrepare, and ISOT. Just add, and as you can see that only few lines of code is required on a single file to add multiple analyzers. So that's that. And collective knowledge of all open source linters. So DeepSource internally covers all the rules from open source linters like PyLint, Flaked, Bandit, PyCode style, PyDoc style, etc. And it has its own custom checkers too. So as you can see, DeepSource Python analyzer currently covers 680 issues, but it is not updated yet. And it also autofix 111 issues. So I'll tell about it in the next slide. So auto remediation of most commonly occurring issues. So as I said that currently 111 issues are auto fixable in Python, and our team is continuously working on increasing these numbers. So let me show you a quick demo, like how DeepSource auto fix these issues. The demo Python repository, and these are the issues that has been caught by the Python analyzer. As you can see that these issues are auto-fixable because auto-fix button is available on them, and these issues don't have auto-fix option available. So I'll go ahead and fix this one. I'll confirm and run auto-fix. DeepSource will generate patch for this issue, and yeah, here we go. So here we can see the diff. This was the code when their issue was arising, and this is the diff where it has auto fixed the code. Now I'll go ahead and create a pull request for this fix. So as you can see, DeepSource is creating a pull request from this fix. And I'll go ahead and check the pull request. So DeepSource has created a pull request for this issue, and as you can see, DeepSource is also checking for code quality using Python analyzer and transformers. Let me show you. Yeah, black formatter is used. So once these checks are done, you can go ahead and merge the pull request. So this is how easy it is to use an autofix. Issues are categorized. As you can see here, that the issues are categorized and sorted on the severity, like performance, bug risk, anti-pattern, security. It is not just a flat list of 1,000 issues like they are in the open source context. So that's one of advantage. And the full description, you can go to the dashboard, click on any issue, go through its description, and here you'll know what an issue is and how you can fix that issue. Less than 5% false positive guarantees. Like DeepSource guarantees less than 5% false positives. And even if you come across any false positive, then you can directly report it from the DeepSource dashboard. Just report it, and our team will get back to you. DeepSource integrates with the most common code review workflows like GitHub, GitLab, and Bitbucket CI, or Circle CI, or Travis CI. So currently code formatting is done by running formatters locally, because CI system don't have the right access to the code. So let's take an example of the black. You have to run it locally on the Python code, then push the code. But with DeepSource, you just have to pick the formatter at 3 lines of code and forward it. Let me just show you. Here you can just choose your formatter. I have selected black, and see just 3 lines of code, and your code formatting is on autopilot. So DeepSource is free to use for open source projects, and if you are an individual developer or a small team, you can go ahead and use DeepSource for free on open source projects. DeepSource also provides a subscription similar to Circle CI and GitHub for large teams, and it also provides on-premise deployments for enterprises. So yeah, go ahead and try out DeepSource. So before I wrap up, I would like to share about DeepSource next. DeepSource is hosting its first virtual conference on June 8, 2021. You can go ahead on deepsource.io/next and check out the speakers and talks and register yourself for free over there. So yeah, that was all from me. Thank you so much for joining.
That's great. So let me see, just gonna switch you out to, can you unshare your slides there? I'm just gonna flip people back to gallery. So thanks, Savendra. I know that was time was a bit tight. She got it with a minute to spare. So you mentioned that there was you said there was a conference, was it?
Yeah.
Yeah, just at the end there. So you just go to deepsource.io and people will be able to find out.
Yeah.
Deepsource.io. Yeah. Sorry.
Just go over to deepsource.io. You'll find it on the banner.
Okay, brilliant. I'll add that on to the announcements as well. The crypt pad that I did in the announcements earlier on. That's where I tend to put conferences and things like that, you know, especially if it's associated with folks who are giving talks here. But yeah, I think I don't know if there's any questions. Lei, did you notice any questions? I know there's a bit of a debate or a bit of a talk, not debate, a bit of a talk back and forth about Nabanita and Rebecca.
Yeah, we have a question.
Yeah,
for
it sounds like a really good platform. So does this support Rust at all? It's for
Yeah, currently it doesn't support Rust,
Okay.
but yeah, we'll be adding more languages in the near future. So you can go ahead and take a look at the deepsource.io and go through the documentation to know which languages are currently supported. Let me just share the link.
Thank you.
Okay, thank you. I think there was one question for Nabanita. Just where is this? It's by Banu. Is scraping Wikipedia or any other website different? Can we use the same libraries or functions?
Yeah, I answered that already.
Oh, did you? I was just going because I thought you were talking to Rebecca, but I didn't know if you answered Banu or not.
So yeah, you can actually use Beautiful Soup for scraping other stuff, but Wikipedia and SPARQL wrapper is specific to linked data. So it's specific to DBPedia, but I don't think it's you could use Wikidata as well. I'm sure you should be able to.
Great. And I think our time is up actually. So if people have any more questions, you can either email dublin@pyladies.com and I'll pass them on to our amazing speakers this evening. So thank you. I should have a sound effect for clapping, but I'm going to do clapping sounds here for you. The details and how to contact them are for the meetup page, but I'll update some of the information that we got from the team from Shavandra as well about the conference. And but yeah, if there's any kind of other information that you want to share, just drop it into the comment section on tonight's meetup page as well, and I will update the crypt pad that I use for announcements. So so I suppose one last thing is thank you to speakers. Thank you, Nabanita. Thank you, Safandra, and thank you to my co-organizer Lay, and also Michael as well, for helping moderate the live chat, and thank you to everyone this evening who joined us. So for next month, we have as I said, we have Lais who will be talking about. Let me grab the information for next month. Tuesday, June 15th, again, Lais will be talking about newbie is not nobody, how you can contribute to communities even if you are new. So the event is already up on Meetup, so is the July event as well, and the August one, when we get all the information, will be announced as soon as I have all the information firmed up. Thing I have to do now is, like all streamers now, that you have to remember to hit subscribe and like the video, and do let us know what else you want to listen to as well. And if you want to talk, give a talk or give a lightning talk or a demo or a workshop, drop us a mail at dublin@pyladies.com. And but yeah, thank you everyone, and I will leave you all to have an amazing evening. And so I will say bye everyone. Thank you again. Till next month.
Thanks. Bye-bye.